Good morning, superhumans. I acknowledge the traditional owners of this land. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. It is an hour earlier than this would normally be for many people around the world because today in Melbourne it is the first day. Actually, I shouldn't say Melbourne, I should say Melbourne, because that's how the locals say it. I suppose I'm a local. I qualify as local. It's the first day of daylight savings, so we have just started an hour earlier compared to other time zones around the world. And I woke up this morning with the feeling, you know, that nasty feeling in your throat when you are getting sick and, you know, it's like you've been chewing on razor blades or something like that. I had that this morning, which is not great. So I may end up not doing a very long live stream today, but we'll just see what happens. Depends whether my my throat holds out. Sometimes it doesn't. I don't know why. I suppose I don't talk very much other than on live streams. This is pretty much when I talk. So last week we put together the EtherUNO prototype, and because I was being kind of silly and not taking a whole lot of care about it, I grabbed a whole bunch of parts off existing boards and I've just transplanted them. So for those of you who were here last week, yeah, you would have seen me use the words aren't coming, the preheater, and then pulling parts off the boards and sticking them onto the prototype. And I've got the prototype right here sitting on the bench. This is what we put together, and I need to get that out of the way. And what else? Okay, so the end result of all of this was the live stream ran way over time and I was diagnosing problems, which was actually cool. I thought it was fun to be trying to figure out problems on the live stream while everybody's watching, because diagnosing problems is one of those things that it really teaches you things. It makes you stop and think about how things are meant to be working and analyze how the failure is occurring. So you could have something where the symptom makes you think the problem is in one area and it's actually being caused by some totally different part of the circuit. And what you're seeing is the end result, not the root cause. So things like figuring out what is causing these sorts of problems, I personally find really interesting. And when I'm putting together a board, my goal, obviously you want the design to be right. You want everything to work. And in a world where everything runs smoothly, what you do is you put down the PCB, you fit the parts, you plug it in, and everything works. And it's all good. It doesn't always work that way. And in some ways, when it does go like that, it's not as interesting. So where we got to last week was I'm trying to remember the point at which we figured it out. So, I've just seen on the CCTV, I've got a delivery coming to the door. Is it? Oh, it's Taj. It's my normal delivery driver. He's here on a Sunday morning. That's really strange. And I can see, based on the package that he dropped off, it's something from AliExpress. One of the many things that I'm waiting on at the moment. But that's just going to have to sit on my doorstep for another couple of hours. We'll wait and see what it is. So we had the board with the problem with the power supply. It was pulling all of the amps that we chose to give it. I started it up with the bench power supply set on 10 volts and I was current limiting it to 300 milliamps, which is a level that was sufficient for the board to power up if it had worked, but probably not enough to actually do things like burn tracks on the PCB if there happened to be a short circuit somewhere. Now, on first bring up of a board, there are many things you can do to play it safe. One thing that I pretty much always do is power it up for the first time from a lab supply with the current limit turned down low. Now, I probably should have started with the current limit lower than that. Like typically I would start with it at like 100 milliamps or some smallish amount. Ideally you want it to be down at a level where it's probably not going to damage parts on the board, like the microcontroller, which might have an ability to sync or source a certain amount of current out of its I/O pins. And Frank just said I should have a geeked up parcel box. Yes. There's a whole story about that. There is... I'm chasing squirrels. Okay, I'm going to chase this squirrel very briefly. There is a very cool project done by Grant on the... so in the Discord, there are a few people who have been very active and have been... Grant is one of the moderators, and he's done a project which is a package vault project. I've got to find the URL for this. So I might come back to this later, actually, but it's this project is very cool. Might follow it up with a URL later. Guru of Nothing, yes. So Grant is Guru of Nothing. So he's done a project where he's got a big steel box which is attached. I think he's bolted it to some concrete slabs outside his front gate, and it is connected. Pancake, hey, good morning. And it's connected up with a linear actuator, and there's like an Arduino type board in it, and cameras and all sorts of stuff. So what happens is that a delivery person puts the package into it, closes the lid, it locks itself, and then it can't be unlocked unless he does it with his phone or through the home automation system. So very cool. Okay, I need to return from that little squirrel chasing exercise. So powering up the EtherUNO. With the current limit set on 300, what we were seeing was were two hot spots. One was around the voltage regulator, which is the 5-volt voltage regulator, I think. Yes, and the protection diode on the input side from the power supply. And so the diagnosis that we got to on the live stream last week was that the voltage regulator was stuffed. It was essentially a short circuit to ground. So what was happening is that the power from the external power supply was coming in, the diode was heating up. Now in retrospect, just thinking about this now, that is strange, because something like a 1N4004 power diode should not get noticeably hot if you're just running like 300 milliamps through it. But the amount of heat coming off it may actually have been very, very small. We were looking at it on the thermal camera, and the automatic gain control adjusts it so that the hot spot that is highlighted on the board, or the hottest temperatures it shows on the board, will always appear as being like a bright temperature. It adjusts the scale. So you could be looking at a board which is almost uniform temperature, and if it's got a couple of points on it that are maybe like 1 degree above the rest of the board, they'll appear as hot spots. But it doesn't mean that they are really dramatically hotter than the rest of the board. They may be only just marginally hotter, but it highlights it because of that automatic gain control. So what we were seeing was heat in the diode and in the voltage regulator. Switching the voltage regulator for a new one straight out of a piece of tape solved the problem. The board powered up. But where we left it last week at the end of the live stream was that I couldn't flash it. My theory was that it was the 18MeG16U2 USB to serial converter chip. Turns out I was wrong, because after the live stream, I went and had lunch, came back and did some diagnostics, and it turned out to be much, much simpler than that. There was actually nothing wrong with the hardware. The problem was that I had pulled the ATmega328, the main microcontroller, off a really old board that I had in my junk box. That really old board came off a Freetronix 2010, I think it was, which was prior to using the 16U2 as the USB to serial converter chip. It had an FT232RL, I think, as the converter, and the bootloader was different. So what happened was, I got an ICSP programmer, plugged it into the board, reflashed the bootloader, and everything magically started working. So, what you see now on the screen with the board sitting there, and it's running, it's plugged into USB, plugged into Ethernet, that is, apart from adding the crystal, so just over, if I reach back, you see that crystal just there, which is hanging off in a strange way. That's not the crystal that is meant to be on the board. That's the 25 megahertz crystal for the WizNet chip, and it is meant to be a little surface mount crystal. You can see there's a surface mount crystal up here, and there's another one over here, these little silver rectangles. So that is the package that this is meant to be. But I just didn't have any 25 megahertz crystals in that 3225 size package. So I just got an HC49 US package crystal, and I patched it onto the surface mount pads. Got the soldering iron in underneath and soldered it on. So that is the only hardware modification that I've made to the circuit since we were looking at it on the live stream last week. So all it was that, reflashing the bootloader on the main processor, and everything started working. So what I'm going to just show you now is a couple of little checks to verify that this is working. And what I've got here is, come on, change it to the desktop. That's better. So what I've got here is Blink, because we have to run Blink. Everybody's got to run Blink. So I'll just hit upload on that, and this will push the Blink sketch across to the board. And I've queued up a few other sketches here that we can use for testing other parts of the hardware. I've already gone through this, but it's kind of interesting. I'll just show you the different things that I check. Oh, it's finished. Alright, so back to overhead, and if you look up in the top right part of the board, it's a little bit obscured because we've got a blue LED there that is really bright, but there's a red LED just below it, so blue LED is power. And if I block the blue one, you'll see the red one flashing on and off. So we've got Blink running, and something that I often do in this sort of situation, just to verify 100% that what I'm doing is really updating the code in the microcontroller, is to change the delay and then just upload it again. And what you can see now, because I just changed it to a 0.1 second delay instead of a 1 second delay, you can see that Blink is now running much faster. In fact, so it's blinking 5 times a second. It's 100 milliseconds on, 100 milliseconds off. So hopefully you can see that, depending on the refresh rate on YouTube. And so we definitely have upload of code running to that board now. So another device that is on that board is the MAC address ROM. And hang on, 50? I thought it was hex address 48. Now maybe it's 50. It's probably just my memory that's wrong. So what we've got here is a sketch which talks to the MAC address chip. So the MAC address chip is, oh okay, James just said if you place a scrap of paper over the LEDs they may show better on camera. I will try that. Let's switch back to overhead. Not sure. The white paper is quite glary. You can kind of see. But I think the part of the problem is the white paper is now picking up glare from the overhead lights. Might make things a little bit better. Oh well. Cool idea. So this board has a MAC address ROM on it. And that's because one thing that really annoys me is when I have to maintain code that is unique to each device. Ideally what you want to be able to do is have standard firmware, ideally even a standard binary. So you're not using something like the Arduino IDE, plugging in a board and then pressing upload. because what that does is compile it every single time. Ideally what you want to be able to do is generate a program, compile the binary, and then push that across onto each of your target boards. So if you're setting up a whole bunch of boards, you should be able to put the same code onto them, and it's actually the exact same blob that is being moved across. And what that means is you can't do things like have a hardwire, word's not working today. You can't do things like set the MAC address in the sketch, because the MAC address then ends up just being the same for every single board, and that's no good. You can't have the same binary blob on multiple devices on your network. So what I did on the Ether 10 and now the EtherUNO is put on a microchip 24AA125E48 EEPROM, and that EEPROM is a little I2C EEPROM. It's a very tiny device. Because it's I2C, I think it's like a, what is the footprint of it? I think it's SOT2, was it SOT323 or something? It's a little 6-pin SOT type device, so it doesn't take up very much space on the PCB, and it's I2C. So, they come from the factory with every ROM pre-programmed with a unique MAC address from a range that has been assigned to microchip, which means that your program can start up, read the value out of the MAC address chip, and then use that as its MAC address when it wants to connect to the network. So, so I included that ROM on the board. Anyway, enough background explanation. Let's have a look at this code. So what this is doing is setting the address of the MAC address ROM, and because it's I2C, it needs wire to connect to it. And then what we've got is this little array, and it pre-populates the MAC, and it's just got all 0 values to start with. So in this particular case, if we don't get a value from the MAC address ROM, the MAC address is all just going to be zeros. So in a sensible program, what you would do is you would make this some default MAC address, which it will use if it fails to talk to the ROM, probably. Unless you want it to fail hard, which is certainly a valid decision depending on what your device is. So then all it does is, what are we doing here? Not very much. Printing some spaces. And I don't even know why this thing is doing that. I think because this got pulled out of a bigger program. I don't know. So what it's doing is it's reading a series of registers. So the register address FA is the first byte of the MAC address in the ROM. And read register is a function that is just down in the sketch a little bit. You'll see that in a second. So what it does is it reads the first byte out of the ROM and it sticks it into the first byte of the MAC address array. And then it reads the second byte, sticks it into the next one. So what this is doing is populating this array that we started back up here, and then it just prints it out. So it puts it into hex format. You can see we're using sprintf, and it's using %02 capital X, which means that it will be capitalized hex values, and it puts the semicolon in between them and prints it. So it doesn't actually need to do anything in the loop. All it does is read the MAC address ROM on startup and then print it. And then down here we've got a function read register. We tell it what byte we want to read, and it starts a transmission on the I2C bus, and it sends a sends R on the bus, and then requests 1 byte. When it gets the byte, it just sends it back to whatever call this function. So this is actually a kind of handy little I2C utility routine. You can use this to just read from registers on an I2C device. So if we just hit upload on this now, This will compile it, push it across to the board, and when this finishes, what it should do is exactly what we've seen in the sketch. It should read from the MAC address ROM and spit the value back out. And hey, look what we've got. It says starting test for MAC address ROM, which is from here, getting MAC, and the value is 0004A3D334A8. Test OK. So that is the value that came out of the ROM that is stuck on that particular board. So what we should get then is a unique value. So for every board that I build, it'll have a different MAC address based on the particular chip that came out of the tape for that MAC address ROM. So in terms of automated testing, and what we're doing here is just looking at the output manually, and what we're looking at here is little snippets that test different parts of the functionality of this board. But this is just the sort of thing that I do as part of my manual prototype assessment. So if I put together a board like this and I want to verify the different bits of the hardware are working, what I'll do is have little programs like this, which are snippets of a test. It's not a full test suite. It's just testing one specific thing. In this case, we're testing the MAC address ROM, and it's just outputting it to the serial console. So for something like end-of-line testing, if we're looking at producing hundreds or thousands of these, and we want to have them done on a production line by a PCBA, and we want to have them all automatically tested, then what we would need to do is integrate each of these things into a test process and have it run these series of tests automatically, and then give a pass-fail result at the end. And if it fails, we want to know why the test failed. So that's actually a really interesting subject, and I've talked about it a little bit in the past, and I might talk about it a bit more in the future as well. I think talking about test systems for production line end-of-line testing is a really fascinating thing. So in terms of automated testing, if this test was being done as part of an end-of-line test, what we would need to do here is, in our code, we would need to check whether we had successfully read from the MAC address ROM, and we would have to have a fail condition here somewhere. So if you attempt to read from the ROM and you fail, or if you set a default value up here and then you attempt to read from the MAC address ROM and you get down to this point in the code down here somewhere, and the value that's in your buffer is still the default value from up here, then you know that you've failed to get a new address, and you can set some flag and output a failure message on your end-of-line testing. So in that particular case, the logic would need to be that because you're not testing for a specific value, which is usually what you do in a test situation, normally what you do is you want a predictable value, and you want to be able to say, this is the value I was expecting to get, like the result, which could be I drove this pin high and now I've read that this pin is high. Or I've got an input which is at half of VCC and I'm doing an analog read on it and I'm getting a value within this range. What we're doing here is we want to know, we can't predict what this value is going to be. There could be anything essentially that comes back out of reading this value. So what the end-of-line tester has to do is have something like a default value, and if it is no longer the default value, then it's succeeded. So, sometimes setting up tests like this are not entirely straightforward. There can be ways that the test can fail in a way that your board has failed, but it has failed in a way that will trick the test into thinking that it's working. So sometimes this sort of thing can be a bit mind-bending. Just making stuff up as I go here. Hypothetically, you could have a situation where you are getting values back reading from the MAC address ROM and they are not consistent. I don't even know why that would happen, but imagine that as a failure mode. You've got to think about how you would check for that, which means that you would probably, in this test, want to do something like read from the MAC address ROM multiple times and then see if you get the same value back every time. I mean, the chance of that being a failure mode is, ridiculously small, but as you're setting up tests, you need to think about these sorts of things. You've got to get yourself into the mindset of what is every single possible way this could fail, and then try to catch it. Alright, so we know that the MAC address ROM is working. And in fact, if I hit reset on that board now, it'll run that test again, and we can see, oh, that's why it was doing that. Okay, this is just... let's get rid of this little for loop that was just printing a bunch of blank lines. That's annoying, and let's upload this again. This way we can read the test. What that would have been doing is, because this came out of a test suite, I think that was basically pushing a whole bunch of stuff down so that you could see distinctly where the test started and ended. Okay, so now it's restarted, and if I press reset, we won't get that whole bunch of lines that push the test results back up off the page. And if we keep rerunning it, you can see we're getting the same MAC address each time that the test is run. So, cool. Now we know that the MAC address ROM is working. What else can we test? There was... I'm just going to have a look over here. Okay, so this one is kind of cool. So this is where we're getting into testing the Ethernet, and this is a link status test. Now, with the Ether 10 and the old okay, I'll cut that train of thought off. Okay, so one of the features with the newer WIZnet chips, so this one's got the W5500 on it, is that they report extra information about the connection. And one of them is the link status. With the W5100, there was no way programmatically from the microcontroller to talk to the Ethernet interface and say, is your link currently active? You couldn't get that information. With the W5200 and above, so including the 5500, we can talk to the WIZnet chip and it will report its link status, which the link status is like a hardware level connection. It's basically telling us that we've got a cable plugged in. So in this case, what we've got is the chip select is set up on pin 10 because I select the same pin as on the official Arduino Ethernet shield because I wanted to make this software compatible. And as I've talked about in previous live streams, that is largely what drove the design decisions around the EtherUNO. The whole idea is that the EtherUNO, from a software point of view, should be functionally the same as if you've got an Arduino Uno and an Arduino Ethernet shield and you mash them together onto the same PCB. And that's what we've got here, which means that all of the example code that is designed to run on an Uno with an official Ethernet shield should just work. You don't need custom libraries, you don't need custom board profiles, everything works. So what I've got is the Ethernet init on pin 10, so that's the chip select pin. And what we're doing in this loop is just reporting the link status. So all it's doing is getting the link status from the driver and then printing it, either unknown, on or off. So if link is on, it means we've got a cable plugged in, and if it's off, it means we don't. So what I can do is hit go on that, and we should start seeing some results coming back up in the serial console in a moment. And we can see there it says link status is on, on. Now, how do we get to see this both at once? I'm going to switch to the overhead, which means that the console is going to be very, very slow. And I'm going, what is going on with that? So I'm going to unplug this. Oop, bring it back into field of view there. So we've got this unplugged, and you can just barely see in the console the word has got longer because it has been unplugged. So there was some weirdness here where the values were jumping around, but now that I've unplugged the cable, you can see that it's consistently off. And if I plug it back in, I'll slide back over here. You can't see what I'm doing. Oh, you can kind of see through the main camera. So I'll plug it in now. And you can see that the link status is now on. So we are successfully detecting the cable being plugged in and reporting it back to the console. Alright, so what else can we look at? SD info. Alright, so there is also a micro SD card slot on this board, and so what I did was just pull off the little info sketch, and don't know if you can see it, but there is a micro SD card just there that I've plugged into it. I grabbed the SD card out of my Phantom drone and stuck it in there, so it'll just have like image files and things on it. But with a card in there, we should be able to interrogate the card and validate that it is there. So SD chip select, I've got set on pin 4, and I won't go through this. This is a very long and very difficult to read program with a whole lot of weird stuff in it. So, you know, things like this. There are some entertaining blocks of code in here. Oh, you can't read that. Let's pull it back to there. So, yeah, so there are chunks of code in it like this. And, you know, this sort of thing you can figure out, but it does take some puzzling. So what I'm going to do is just hit go on that and push it across to the board. And we should be able to use this to determine whether it can communicate with the SD card. And as I've said before, and I've mentioned this a few times on previous streams, SD cards are just SPI bus devices. So that's why we've got SD chip select. We've got a select pin, and we can treat the SD card as if it's an SPI device, and that's because it is. So, which raises some interesting possibilities. One really cool thing I've seen is, I don't know, one of you probably know where this is. I can't remember where it was. There was someone who made, I think it might have been a debugger or some kind of a device like that, that plugged into the SD card slot of a target board, and that I thought was pretty cool. So you can, if you have a board with a micro SD card or an SD card slot on it, you can misuse that slot as a way to connect SPI devices. And it doesn't have to be an SD card, it could be anything. As long as it makes the electrical connection, you've got a full SPI interface right there in the card. Anyway, back to here. So what have we got? Okay, SDFAT version. So it's showing us a version there, which I assume is the version of the file system. I don't even know what those values mean. Okay, it says type in a character to start. I'm just going to say A, go. Oh, failed. Interesting. So to disable a second SPI device. Alright, I'm going to set this to 10 to disable the Ethernet controller. I don't know if this is going to make any difference. Let's find out. We'll push it up and see if we can then communicate with the SD card. So I've tried this sketch in the past. In fact, I used this sketch this morning and it worked just fine, but it might have been that I did that before the Ethernet interface was initialized, and therefore it needed to be disabled. No, it's failed again. That's really interesting. Okay, so let's move on to the next test, because the next one tests the SD card as well. It's another test that also exercises the SD card, and this is SD web server list. So what this does, come on, drag down. This has got the dead beef MAC address hard coded into it. This is just one of the examples that's bundled with the IDE. So what it does is set up the Ethernet interface with a web server on port 80. It's got a hard-coded MAC address on there, and it reads from the SD card. It outputs some information on the serial console, tells us files it's found, begins the Ethernet interface, and then we can connect to the Ethernet interface. We can connect basically with a browser, and it should show us what it's found on the SD card. So this will be exercising both the SD card and the Ethernet at the same time. So let's shove that one across. Yeah. Yeah, is it up? Okay, uploading. Sorry, drink time. Alright, done uploading. What is going to happen here? SD card in it failed. This is interesting. I wonder if it's just because I moved it around or something. Maybe I'll just power cycle it and see what happens. Alright, let's hit reset. Aha, yeah, okay. I suspect that when I was moving the board around earlier, I picked it up and waved it at the camera. I might have moved the SD card in it because it wasn't connecting. So what we've got now, after I unseated the SD card and clicked it back in, is that it's now saying volume is FAT32. So that makes a whole lot more sense than saying the 10100 value that it came before. So it's saying files found en route. It's got some folders in there, and then you can see it's going down into the subdirectories, listing the contents, DJI, blah. Oh look, what is that? MISC THM. So this is obviously something related to the Phantom, which is the drone. I don't know what these files are. THM and RLV files. Log, and it's got some images in the trash. Nothing particularly interesting, but at least that shows, oh look, there's nothing in DCIM, so there are no actual images on this folder. Thumbnails. Okay, Joe and On said those are thumbnails. THM. That certainly makes sense. Alright, so now if I bring up a browser, let's bring this over here somewhere, and let's see what we can pull up. So 192, what am I going to pull up? 125, and cool. So a couple of things. Firstly, in the browser, we got a value coming up, and you can see we've got DCIM, MISC, F7, and Trasher. These ones have been truncated because of the DOS file conventions. But yeah, you can see the files, the folders there that have come up in the web browser being served off the EtherUNO. So it's reading data off the SD card and then serving it to us as a web page. And looking in the console, you can see a little debug message in here. It says done, get HTTP 1.1. So if you keep your eyes on this, see it's just got done on there 1, and I hit reload, it now says get HTTP 1.1 again. So the console is reporting each time that web page is being loaded. So we're getting confirmation. Basically, we've got complete round-trip confirmation here. We are sending a request to it, an HTTP 1.1 request for a web page. It is reading its SD card, formulating the page, putting it all together, putting the HTML chunk together that needs to come back, and sending it to us. Actually, I wonder what it looks like from a page source point of view. Super fun, super simple. And in fact, it's not even valid HTML. Look, it doesn't have the open and close tags or anything. It's just sending us files and then an unordered list of the things that it wants to send. So where is it doing that? We're doing volume files and somewhere content type, oh, this is the response header, so it's sending the HTTP 1.1 response header, and then it's sending this. So let's just make this a little bit more realistic. Let's see, title. I mean, this is kind of silly doing this, but head, and then let's make it open the body tag, and then we've got files, and then after we've done all of that stuff, where is it? File not found, content. Where is the loop where it's doing the thing? Uncomment the serial, list files. Well, so far we have opened the HTML document. We haven't closed it. If we now push that across and load that page again, we should have the start of the document making a little bit more sense, looking like a real document. So this is what the output looked like before. It's a very incomplete HTML document. So that's now loaded again. Let's reload this. Reload, view source again. And now we've got HTML, head, title, close head, open the body, and then down the bottom here we should add on close the body and close the HTML. So anyway, I don't know why I was screwing around with that. It just annoyed me that it was outputting invalid HTML. So list files. So after list files, alright, so I don't really have anything better to talk about today, so let's do this. I'm just going to add this on the bottom here. So client.print line, and we want to close the body tag and then close the document. So I'll send that off, and now we should have an HTML document that looks a little bit more sensible. For people that care about HTML documents looking sensible. Obviously there's way more that you would need to put in to actually make this a valid, like a properly valid document, but well. So now reload this. I wonder if I've broken the HTML. And view page source. And look, now we've got a close body tag and a close HTML tag. So now it's outputting something that is closer to what an HTML document should look like. But it doesn't really matter. The browser figures it out anyway. Alright, so now I'm curious to go back to that other test. So that was the SD web server list test. The SD info thing that we did before. I'm going to hit upload on that again because I want to see what output this is giving. I can't remember what it was doing earlier. Oh, I just noticed that there has been a large increase in viewers on the live stream just in the last few minutes, and I wonder if that is because we are getting closer to the normal start time for this live stream. Everybody was caught out. Well, not everybody. Some people were probably caught out because I started an hour earlier than usual. Alright, so now we've got the little test thing running again. Type any character to start. Oh, it still says SD fat version is 1011, whatever that means. Magic numbers. I hate magic numbers. So let's try this again. Aha, now we've got values. Init time 31 milliseconds. And card type SDHC, manufacturer code, OEM, blah blah blah, version, serial number. So we've got a whole lot of info coming back off the card. Oh look, it was manufactured in June 2015, so it's a bit over 5 years old. And we can see the size of the card, partition table, blocks, free space, all sorts of stuff. So yeah, this is the exact same code that we were trying to run just like 15 minutes ago, but now it works. And it was just because, as I said, I think it was just because I didn't have the SD card shoved right in. And the other thing is that I don't have any spare card cages for that particular footprint, because normally these boards are made for me in a factory and they have all of the stock. So, and that's actually one of the reasons that I was pulling bits off an old board in order to populate this one, because most of the regular parts, like, you know, just jelly bean parts like resistors and caps and all of those sorts of things, I've got plenty of those. And even things like microcontrollers and stuff. But there are some things that I just don't have. Like, I didn't have any of those micro SD card cages, so I had to pull that off the other board. And the way those particular SD card cages work, they've got a plastic base which has an unfortunately low melting temperature with a metal cage over them and the contacts. So they are remarkably hard to remove from a board without damaging them. And I think the one that is on this prototype now is slightly warped because of the plastic getting very, very soft when I was removing it from the other board. And so that's probably contributing to the SD card not being so reliable when I plugged it in. Okay. Now, where to from here? I have no idea. I suppose what I should do is start paying attention to you and looking at the chat. Okay. Oh, Modbus RTU. Okay, so I'm going to quickly look back through a couple of things. So Jean-Christophe Duperon said, where can I find the Superhouse Eagle library? At the moment you can't, and I would be perfectly happy to share it. What I need to do is figure out how to go about sharing it with the new managed library mechanism. So with Eagle libraries in the past, library management is a hard problem. So I'm just imagining all the directions this bit of conversation can go. Okay, a little bit of history. When I started Freetronix back in, when was it, early 2009 or whatever, mid 2009, I can't remember the exact date, the Eagle format for its design files, for libraries, for everything else were basically binary blobs. So sometime after that they switched to using XML. So if you look at a .board file or a .schematic file in Eagle now, it's XML. You can actually just read it, and it's as readable as any XML is. You can look at it and see net names and coordinates and values of parts. You can manipulate the designs externally if you want to. You can write scripts that will process Eagle projects and modify them. And you could do things like replace parts. You can do all sorts of stuff. Now, that in itself is kind of moderately interesting, but what is really interesting about it is that XML is, depending on what you stick inside the XML, obviously, you can do nasty binary sort of things inside the XML. But XML, when it's used for storing things in a sort of nice text format, is diffable and versionable. You can store it in GitHub or Git. I say GitHub because that's kind of, I don't know, it's like saying hoovering for vacuuming. So you can look at it in Git, and see diffs, and the diffs can actually make sense to you. You can even, at a pinch, merge things together. And this is the key of the point that I'm getting to with libraries. The really big problem with libraries is, how do you handle multiple people working on the libraries and merging parts? So if you think of a library as being a single document, I'm trying to think of analogies for this. I don't know. So imagine it's an essay or an article, and it's a big chunk of text, and you've got multiple editors working on that article at the same time, and they're working in totally different sections of the article. You need some kind of a software system that is going to allow that to happen. And for anyone that's done software development, you know of this. It's the classic multi-developer source code management problem. And libraries for things like Eagle or KiCad or whatever face this exact same problem. So the challenge for the developers of those tools is, how do you manage the libraries in a way that allows collaboration and versioning, multiple users, and all of these things, which are difficult problems to solve. And getting back to where I was 5 minutes ago, the early days of Freetronix, what we were doing, when I say we, I mean me and Mark Alexander were the two that started it. The problem that we faced was that we wanted to have common footprints for certain parts. In fact, we wanted to have common footprints for everything. We wanted to be able to be working on two different boards and have the same 0603 resistor footprint in both of them. It doesn't make sense for me to have a footprint and for Mark to have a footprint. And it was a real pain. We actually ended up in the situation where for a while we had a Freetronix Eagle parts library, and there was one of them, and we would have to try to coordinate between us. And we had it stored in Dropbox. So what we could do is, and it was in a shared Dropbox folder, so both of us could work from the same library. But what would happen is that if I needed to start editing it to add parts to it, I would need to make sure that what I had was the latest version of it and edit that, and that he was not making edits at the same time, because we had a contention problem, and he'd end up with corrupt libraries and all sorts of painful things would happen. It really wasn't very nice at all. And what we ended up doing was we had, so this is a horrible solution, but it was the best we could come up with at the time. What we had were three libraries. We had a centralized Freetronix library, so we had one library just called Freetronix. We had one library called Freetronix John and one library called Freetronix Mark. And we could both edit our own libraries and know that we weren't going to be causing any problems for the other person. So if I wanted to add a particular IC that I was using in a project, I would create the parts for that in my personal library, and I could always save it. And so we ended up using parts out of each other's personal libraries in our own project. So if he'd added a part and I wanted to use it in my project, I would pull it out of his library. So we ended up with the original master library that we had been trying to collaborate on, and then we had our own one each. And what that meant is that if you wanted to open a project in Eagle, you would need both of our personal libraries and the original Freetronix library. Otherwise there would, well, with Eagle, one of the nice things about Eagle is that it does embed a lot of that data within the project. But if you want to go back and edit the parts, you need the original library, or to take the part out of the project and stick it into your own library and then edit it there. Anyway, lots of hand waving and going around in circles and confusing situations where you might have a copy of it in your personal library and then you have another copy of it somewhere else, and you don't know which version of that particular part you used when you last produced that board. It was all a nasty situation. Where am I going with this? That was a little bit of a disjointed rant about the pain of using Eagle libraries early on. So all of this question came about from Jean-Christophe's question about where can I find the Superhouse Eagle library. So since then, the library management system has been massively revamped in Eagle. It now has managed libraries where the library is stored in their cloud management system. And so in my case, I have 2 main computers, well, 3 if you count the one that's at Chris's place. So I have 2 main computers that I use for editing PCBs and schematics. There's my iMac right here, and there is my MacBook Pro, which I use when I'm sitting in front of the TV and working in the evening. And so I've got Eagle on both of them, and and I've got all of my libraries now set up as managed libraries so that I can have 3D parts associated with them. So I either generate the parts using the internal part generator, or for complicated things where I actually care about making it all look really nice, I might generate the models myself in Fusion 360 and then import them into the library and assign them to the footprint. So this gets us all the way back to the original question, which is I haven't actually looked at what is involved in sharing a library using the new managed system. So from just seeing the announcements that have come out from Autodesk over the last little while, it looks like they've made some changes in terms of being able to collaborate on libraries. When managed libraries were first released, it was like a one user per library situation. You could create a managed library, it would go into their cloud management system, but nobody else could access it. I think that was the case. You could export it in like a backward compatibility mode where you would export it as like an old style library, but then you lose all of the benefits of the managed library. So what I need to do is figure out how to share my library. I don't have, let me see. I actually have a whole bunch of libraries. There is not one. Let's have a look at how it is. I've just, I'll launch Eagle and might as well show you a couple of things. So, while I'm waiting for that to open, what else? So there was a question from Austin's Creations about using the P9813 LED driver. I've never even heard of that one. Spent the entire day on Zoom trying to diagnose them with someone. My final thoughts are they are junk and very finicky. I don't know. Sorry, Austin's Creations, I haven't seen that particular LED driver. And if you've had that much trouble with it, I'm not inclined to look into it or want to use it myself. So Mike O'Connor said, this is a throwback to a previous conversation. So he's said, I found a board with 32 relays which supports Modbus RTU. That's interesting. So that sort of device could be used as a replacement in like my switchboard or at the moment I've got the DIN rail mounted relays connected to an Arduino, which is using relay drivers to turn them on and off. But something like a board with 32 relays on it with Modbus RTU interface could be interesting. It'll be much nicer to have a device that you can stick in the switchboard and then connect some kind of a communications interface with it and send it commands and turn channels on and off. This is an interesting question. Johnny Bergdahl said, any solutions to get TLS working over Ethernet? The short answer to that, if you're talking about the context of something like an EtherUNO or an Ether10, with an ATmega 328 on it, short answer is no. They are doing TLS. Okay, so for those of you who don't know what we're talking about, and I don't even know what I'm talking about, I'm just making this up as I go. TLS is in relation to encryption and security on a connection. So being able to connect to like an SSL enabled web server, and it's used for different purposes. But the thing is that to do crypto in any way that is even vaguely sensible, you need more processing power than is available on something like an ATmega 328. So on an Ether 10, EtherUNO, those sort of class of boards, short answer is no. It's not really feasible. Even things like the ESP8266, which is a 32-bit processor, it's much faster. It's got a lot more memory. I think there is a library. I've never used it, but I think there is a tiny TLS library or something like that. But trying to get TLS working on something like an ESP8266 class device, which is way more powerful than an Arduino Uno, is really, really pushing it. It's not going to be very good. And you really need to be getting up more to the sort of ESP32 sort of class of device before things like TLS become something that you can practically integrate into your project. So doing it over Ethernet with this sort of board, not so good. Now, what were we doing? That's right, I was opening Eagle, because I was going to show some library stuff. Now I've just got to find a project that I can open that is not going to be too sensitive. Alright, D1Zig, okay, this one. This little project is one that no one has even heard of before, and you will be hearing about it, but not just yet. So this is a little project, D1Zig. It's a Zigbee interface for a D1 Mini, and I have a prototype right here. In fact, I'm going to hold this up to the camera. This is a continuation of my Zigbee to TAS motor project, making a Zigbee coordinator using an ESP8266 and TAS motor. And let's see if you can see this. So that is a D1 Mini with one of these D1Zig boards on it. I'll pull it off. That's the D1Zig board. It's a D1 Mini shield with a Zigbee chip on it with a power amplifier, so it's got decent, reasonably decent coverage. And the idea is that the two of them get smooshed together like that, and they make a teeny tiny little package. And I've got a cutout on this side. Let's see if you can focus. Got a cutout on this side for the USB socket so that it clears, and the boards are separated just by the spacer. The idea is that what I'm going to do is just solder these together directly. So the whole thing is a Zigbee coordinator that is like half the size of a box of matches. You just plug it into USB and away you go. So that is the project that is here. And let's see. So what I was talking about was libraries. I just can't keep my mind on track today. Now, library manager. What have we got? Now, I got this idea from SparkFun, actually. I saw the way they were organizing their libraries, and I quite liked it. So, in use, so there are some SparkFun Eagle libraries. Let's see if I can move this across. Now, the font is quite small on this. It might be hard to read. And you can see, for example, I've got a couple of SparkFun's libraries loaded. There's SparkFun capacitors, SparkFun connectors, SparkFun switches, and what they've done is broken it up into sections so that you don't have a single library that has got 1,000 parts in it. You might have 20 libraries that have a smaller number of parts each, like 50 parts each or whatever. So then I followed that same basic structure when I made my own. So you can see, for example, Superhouse connectors. There are 185 revisions of that. I obviously spend a lot of time messing around with connectors. And so what I've got is, I'll just read down them: connectors, discrete semi, displays, ESP-prog, ESP-flash. Now the ESP-prog one is going to be obsolete. ESP-flash is the new version. Filters, fuses, ICs, jumpers, LEDs, MCUs, modules, oscillators, regulators, relays, sensors, supply symbols, switches, symbols, and test. So what I can do is basically go into, if I'm going to place a part on a board, I go into the appropriate library. So let's just open one. Discrete semi, connectors. Let's have a look at connectors. That's probably got the interesting stuff in it. Oh, edit. It annoys me you can't just double click there to edit one of those libraries. Alright, so what connectors do we have in here to look at? I need to move this over here so that you can see the whole thing. And you can see I've got many footprints here and many 3D packages and symbols, a smaller number of symbols. And the way I've arranged this, actually I'd be interested to hear other people's opinions on this. This is just, the best I could come up with in terms of my objective. Let's look at a specific example. So let's have a look at M06. So this is a header which is a standard pin header. And it's available 106. Do I want 6? I'm just trying to think of the best example, the one that's going to show you the most interesting things, with different size variations and that sort of thing. 127 plain, 104. Let's try 101. No, I'll start with the 6. This doesn't have all of the variations in it that I would like to show you, but we can get back to that because the 1x6 header is like a standard thing. Alright, so M06, and if we go and look at that in detail, so this is standard 6-pin header and screw terminal variations. Alright, so what I've got here are, let me see, 6 versions, or 6 different packages for the 1x6 header. Now part of the reason for this is I think these all have the same, these ones would all have the same footprint, but I've created different packages because I wanted different 3D models. So this is just the way I've associated them. So if we have a look at M06, you can see, let's just scroll down, what else is highlighted? Nothing. Alright, you can see here 6 footprints. These footprints, I think, are almost identical. So if we look at just the 1x6 footprint, that's the standard one, you can see that this is just the regular 1x6 header. It's got silkscreen around it, name and value. Oh, and one other thing that I've changed recently, this is something that I have debated with just with myself. I haven't debated it with anyone else, so I would like other opinions. What I used to do was put the point of origin for all of my parts on pin 1. And that was for connectors. And that was just because that's what I'd seen other people doing. And it turns out to be annoying in multiple ways. So if you run a pick and place machine, what you need to be able to do is take your design, like ideally you want to be able to import your design file into the pick and place software and have it automatically set up all of your placements. And that might be either by exporting a Centroid file, or which has the XY coordinates, or it might be by opening the native project. And in the case of OpenPNP, it can directly open Eagle files. So, and because I use Dropbox to synchronize it, I can be on my pick and place machine and just go in OpenPNP, I just do import Eagle and I select the board file and boom, it sets up all of the placements for me. Now, the reason I mention that is that the placements, the coordinates of the part that you put on the board determine where the machine picks up the part from the feeder and where it puts it down on the board. And now I don't use my pick and place machine to put pin headers in the board. So this is not directly relevant here, but it's an interesting example. Imagine you have a connector like alright, so you're using a USB-C connector. A USB-C connector has got it's a rectangular-ish metal thing with a flat top on it. So it is quite feasible to pick that up on a pick and place machine. And I'm pretty sure Sion uses his pick and place machine to put down USB connectors. So what you can do is pick it up and put it down on the PCB by using the nozzle on the flat part of the top of the package. So if your origin is on pin 1, that is a real pain because it means that your pick location has to be offset relative to the centroid position of the part. So what I've ended up doing is putting the center. So this is basically the habit I've got into. Even for parts that I'm not putting on with the pick and place machine, like with pin headers, because the pick and place machine just can't pick them up, what I do is always make the physical center of the part the origin of the part. So that's the 0 coordinate. So what you can see here, see that little, if I zoom in, you can, oh, it doesn't get bigger. There is a little cross right in the middle there. That is the 0 coordinate for this particular part, and it is right in the middle of the part. Now that means that for a linear part like this with an even number of pins, the 0 point is in between 2 pins. If it's an odd number of pins, it'll be directly on a pin. But the idea is that the center is always the physical center of the part. So other libraries I've seen, other Eagle libraries, like if you look at, I'm not sure how SparkFun do it, I can't even remember. We could open it up and find out. Pretty much all of them use pin 1 as the point of origin, and that can be really, really frustrating. Alright, so let's get back to here. Where are we? Okay, so M06, and if I click on that footprint, so you can see on the right hand side of the screen, can we zoom? No, we can't. Oh well, doesn't really matter. Oh yeah, that'll make it bigger. So we've got the standard footprint that we were just looking at, and if I go down to the next footprint, so we've got 1x06, and then I got 1x06p, click on it, see, it doesn't change. That is actually just a copy and paste of the exact same footprint. In fact, oh, not copy and paste, I probably just went duplicate and then renamed it. And then 106p below, it's the, once again, exact same footprint. So in terms of the board that is generated by putting these parts down, it's going to be the same every single time. Like if I put down that part or that part or that part, let's see, is that one the same? Yes, that one is the same and that one is the same. Now I've skipped over one of them because I think it's a little bit different. This one, yeah, you can see there that I edited the silk screen. It's got a straight line along it, whereas all of these others, the silk screen kind of wraps around the pins. That one is a variation. But what you have to do if you want to make multiple 3D packages or multiple versions of a part that you can place on a PCB is make separate footprints. And that's why I have 6 footprints that are exactly the same, with the exception of this one, which I've edited slightly. So that is one of the limitations of the way the library format works in Eagle. But that is necessary because the 3D packages are associated with the footprints. So if I click on this first one, so 106-P, you can see it's highlighted. This is the 3D model for it down here. And if I go on 106S, where is it? It'll be, oh, there it is. That is the 3D model that's associated with it. So you can see it's highlighted just there. So I've got different 3D models. Now if I click on that 3D model, do I get a preview? Yes, I do. So 1 by 06S means stacking. Oh yeah, so that is the, why does it say stacking? It's the one below it. So that is a socket, and then the 106P is pins. The 106 is just the footprint on the PCB with no 3D model associated with it. So if you wanted a PCB where you just had a plain row of 1 by 6 on the board and there was no connector associated with it, maybe you don't want to populate it, then I would select that one. Now, the point I made very badly before, I didn't say it very well, is if I am designing a PCB and I put this part down, the 1 by 06, or I put this part down, the 1 by 06P, or this part, the 1 by 06S or the ST, it's going to make no difference whatsoever in terms of the PCB that is generated. Those footprints are exactly the same. They were duplicated from each other. So it's going to generate the same geometry, the Gerbers are going to come out the same, the board is going to be exactly the same. So from a PCB manufacturing point of view, it doesn't matter which one of those I pick. The only reason that I have multiple footprints there and multiple variants of this part is so I can have different options for the 3D model that's associated with it. So this one, for example, a 106-XST for stacking header, it's this model. And if we click on that one and get a preview, let's see, you can see that it is a socket with the stacking pin sticking down through it. So then when I take this design, so if I put that part down and I then synchronize it with Fusion 360, or if I use this library in Fusion 360, my 3D model of the part will have that stacking header in it, which is then useful if you want to do things like, well, it's useful for generating a preview, but it's also useful for things like checking clearances and making an assembly where you take your board and you integrate it into other things, like design a case around it. You might want to add a shield on top and then check all the clearances. So yeah, I really like having 3D parts associated with all of this. I think this is one of the most powerful things now about Eagle is its tight integration with Fusion 360. And I'm trying to avoid going off and chasing another squirrel here. There's the whole discussion about Fusion 360 licensing that came up a little, over the last couple of weeks because of their changes to the free license stuff. My personal use case is that Fusion 360 and Eagle are the two pieces of software that contribute the most to my productivity and to which my projects are the most closely tied. So if I was just doing this as an occasional hobby thing, or then I would use KiCad for sure. I'm trying to think of an analogy for this. Okay, so if you are a visual editor and your whole life is editing photos, then and you get paid for editing photos, that's where your money comes from, then you'll probably pay for Photoshop. If your income is not directly tied to it, then you become much more price sensitive about things, and so you would probably use something like GIMP instead. And okay, what I'm trying to do here is separate the whole question of open source versus closed source more from the point of view of whether it is worth paying for something. And I'm really trying hard not to chase down this little squirrel hole. I don't see this as being an open source versus closed source issue. I see this as being more of an issue of, are you, is your work tied to, and your economics tied to the performance of a particular piece of software? And if it is, then you should feel comfortable paying for it, whether it is open source or not. Now, if there is a piece of software that that is critical to your work, and you use it and make money from it, then I think the developers of that should have the option of being remunerated for it, even if it's open source. So if you have people who are contributing time, okay, a good example of this is Octoprint. So I use Octoprint. It's totally open source. Anyone can use it free of charge and not feel bad about it. It's released as open source software. I have it running on my on both of my 3D printers, both of my active 3D printers. So that thing up there, Octoprint, is running on that little Raspberry Pi and controlling my 3D printer. I could be using that and not paying a cent for it because it's released as open source. But I support Fussel on Patreon because I want to see development of that continue, and I am getting benefit from that work. So I want to be able to contribute back, and it makes me happy to pay to use it. I want to pay to use that software because I'm getting benefit from it. And I think many people think of open source software as being like something free that is just handed to them, and you can grab it and run away and use it to your own advantage, which you can, but someone put in a lot of time and effort into creating that tool for you to use. So if there is a tool that you use that is important to you from a work point of view, and potentially you're even making money from it, then I think supporting the people that created that tool is the right thing to do. So that is why I do things like support Octoprint development by donating on, and the mechanism in that particular case is Patreon. But that's like, in many ways, I see that as being similar to if there is a particular piece of software that's got a subscription fee for it, and I pay for it, and I use it, and it benefits me, I'm getting productivity gains from it, then I am perfectly fine with supporting the people that put in all of the effort up front to, and ongoing, to develop that tool which I'm benefiting from. So that's kind of my take. So at the moment, I have used KiCad a number of times on a number of projects. I kind of fumble my way through it. I'm certainly not comfortable in it. I can use it if I have to, but where I'm really productive is in Eagle, just because of what I've been using. If I switched to KiCad as my primary CAD tool, then I would also want to be contributing back to KiCad development. And in some cases, that is as simple as sending some money, like a small amount of contribution to someone, if you're not in a position to actually contribute back with development yourself. So I suppose my message is, it's not so much about whether something is open source or closed source. That to me is that's a really important issue. I think it's critically important. But what I'm trying to highlight right now is that no matter what tool it is that you use, whether it's open source or closed source or whatever, wherever it comes from, if someone is putting in the hard work to create that tool and you are getting benefit from it, then the right thing to do is to try to support those people and help them to continue to develop the tool that you are benefiting from. I mean, it's if you think about it from a purely self-interested point of view, then you want that development to continue, and being able to support that development is something that will help the continuing ecosystem around the tools that you rely on. So I have no problem whatsoever in paying a license fee for Eagle because it is a tool that gives me a huge amount of productivity. If I was using KiCad as my primary tool, I would have no problem whatsoever in contributing back to KiCad development because it would be a tool that would give me productivity. Anyway, a little bit of a rant on the side. Where was I? That's right, I was talking about libraries. I really went off the rails there for a little bit. And so I've got these 6 different footprints, one of which has a slight variation, and they have different 3D models associated with them. That was the point of what I was getting to. So on the M06 header, it looks like, so if you look at the devices down here, however many that is, I don't know how to count that, but it looks to me like 30 or 40 devices that I've got in this particular library. But then if you look at the footprints, there are far more footprints than there are devices, and far more 3D models than there are devices, because I've created all these different variations. Now you can see, if you look at the list, hang on, you can't even see what I'm looking at. Desktop, please. Give me a desktop view. Come on, desktop. Switch to desktop view. No, not working. Something has gone wrong with my switcher. So, desktop view. There we go. So, just to repeat myself now, so it looks like I've got maybe 30 or 40 devices here in this column, and then in the footprint list to the left, just to the right of it, you can see there are way more, because there are multiples for each of these. And now you can see a whole lot of repetition here in the structure, and that is because I've tried to be consistent with the way that I name these particular footprints. And so you can see here in the M06, we've got the 106, which is the plain one. We've got a dash P, which is pins, dash P below, which is pins, but the pins are sticking down below the PCB instead of sticking up from it. We've got PRA, which is pins right angle. Maybe if I... So that one is like that. It's the right angle pin header. And the other thing is that there are 2 variations of a right angle pin header. You can get the version that looks like this, where the pins come up and bend, and then there is a spacer block on it. Or you can get the one where the pins come up, there is a spacer block, and then they bend, and it sits up higher above the PCB. So there are all these different versions, type 1 and type 2 of right angle pin headers. So then there is the 106S, which is the socket, and the ST, which is the stacking socket. So socket with stacking headers. And you can see that for the most part this structure kind of repeats. In 104 we've got the standard 104, and then we've got a 104 in a 1.27 millimeter pitch. There's a 104 in a KF2510, which is one of those little headers with the keyed things on it that you plug in. 104P for pins, 104S for socket. So they aren't all, I don't have exactly the same thing in each of these. It partly depends on what I've needed over time. So there is no, like with this one, the KF2510, that is the little keyed socket, which is in, little pin header, which is in 104. I don't have a 1x6 version of that. Oh, there's a, actually you can see there's a 1x2 version, a 1x3 version, and a 1x4 version, but I haven't created a 1x6 version just because I haven't used it. There is a 1x6 version of that, but I haven't used it. Oh, Pancake Legend, thank you for that super chat. I really appreciate it. Like this. So does that mean that you did that contribution to support content? I think, anyway. I think that I missed the comment earlier because I had that little chat thing in the background. I think that's in relation to what I was saying earlier about supporting the people that create the tools that you benefit from. So thanks, Andrew. So what I've got are, so as I was setting up this library, what I've tried to do is be consistent about each type of header. So if I've got a 1 by a pancake, yeah, your knowledge is useful for me too. I have learned a few things from you. So as I go through and set up like a 1 by 1 pin header, 1 by 2, 1 by 3, 1 by 4, I try to make the same variations and name them the same in each way, in each one. And then down here you can see I've got 2 by headers. So I've got 2 by 3, 2 by 5, 2 by 6. So I've got in the 2 by 6 variations, for example, there is a standard, hang on, what is going on? 2 by 6, no. Let's look at 2 by 3. That's a more interesting one because of the variations. 2 by 3, so a standard 2 by 3 as a plain header, then a 2 by 3 as a shrouded header. So this is IDC header on the board, and then 2 by 3 ICSP. The reason I've done this is that I've got, and then ICSP ST below. The reason I did this one specifically, which is actually almost the same as the standard 2 by 3, is that I've got a symbol in the library which is the ICSP header for an Arduino, and it has the pins coming out with the labels on them. So normally what you would do is if you're designing a project with an ICSP header for an Arduino, you take a 2 by 3 header, you stick it down in your schematic, and then you look up the reference. And in fact, on my little rulers here, let's stick that on there. So I've got that ruler overhead. My little electronics ruler, 180 millimeters long. It's got a bunch of useful things on it, like LED pinouts and examples of track sizes and Ohm's law, and there's an FTDI header pinout. And down here you can see there's an AVR ICSP pinout. So it's got MISO, VCC, etc. And it shows you where those signals are on the header. So typically what you would do is throw down a 2 by 3 header and then look up a reference and see pin 1 is meant to be connected to MISO. And so you would then do that link. But in your head, you are having to do that mapping. I like to try to remove any potential errors from the process. So what I've done is created, if I come back to my desktop view, so I've created an ICSP device, and it has this particular pinout. Now where is the symbol for it? ICSP, okay. Oh, you can't see it in this preview, but these pins have the signals already on them. So pin 1 would already have MISO on it, pin 2 VCC, whatever. So the idea is that instead of just putting down a generic footprint into the project, I put down a specific ICSP header part into the project, and the symbol in the schematic looks the same, the footprint is mechanically the same, but the nets on those pins are specifically named. So when you're working in the schematic, it is super obvious if you make a mistake, and you don't have to think about it. There is no translation of, oh, pin 1 is MISO, so I've got to connect to pin 1. It's just, that is the MISO pin. It's got that label on it. Okay, that was another squirrel. Alright, so 2 by 3 is what I was talking about. So I've got 2 by 3 in plain, in shrouded, pin headers, and in socket. And once again, they all have their own unique 3D models associated with them. So I put down the particular variant that matches the 3D model that I want to have in the project. And then everything comes out fine. All right. James said, I've been using Arduino for 10 years and finally used ICSP last week on a project to bootload a 328p to use the internal 8 MHz clock. Yep. I've got a painful clock story. Do I chase this one? No. There's a story I think I've told quite a long time ago about on one of the prototype boards for the ArduSat payload processor module, which had, was it that one? Yes, it was that one. It's the one with the 17 MCUs on it. And I messed up the fuse settings on the main processor, and I put it into a mode where it required an external clock. So things like having a... Oh, Aaron! Wow. No, you didn't need to cover shipping, but thanks for that. That's really generous. Okay, sorry, I was distracted by Aaron. Thanks, Aaron. So I messed up with the fuse settings on the MCU, and I put it into the mode. So microcontrollers, AVR microcontrollers in particular, I mean it's different for different types of microcontroller obviously, but AVRs have a couple of different clock modes. They can either run off an internal oscillator, they can run off an external crystal, or they can require an external oscillator, in which case you need to feed a clock signal, like a square wave, at the correct frequency directly into the XI pin. So normally there is the XI and the XO pins that you attach the crystal to, and the microcontroller itself uses the crystal as to generate the frequency. But if you put it into the mode where it expects an external clock, it won't excite the crystal. It just sits there like a brick waiting for a square wave to come in on its XI pin. And I set that as the mode and I couldn't recover it. So I had like a one-off satellite PCB prototype that I bricked because I had the wrong value in the fuse setting. And I ended up having to generate a clock signal out of another MCU and then link that across, and that allowed me to recover the processor and then change the fuse settings, and I breathed a big sigh of relief. But that was one of those moments where I did it, and then once I realized what I had done, it was like, oh my god, I've killed this board and it's unrecoverable. And it's like the only one of this very important prototype that's meant to be going into space. But there are usually ways around things. So, what it is, 11:39. I've got to get onto stuff in the chat, but I've done this big detour into Eagle libraries and I haven't answered the original question. The original question was very simple. Where can I get the Superhouse Eagle library? The simple answer to that is right now you can't, because I haven't put this anywhere. And then I ended up detouring into this big discussion of Eagle libraries and footprints. So I'm quite happy to share my libraries. Where's my cursor gone? There it is. Okay, so as I showed you before, I've got that collection of libraries. This is my Superhouse connectors library, and I've got other libraries like discrete parts and ICs and MCUs and modules and switches and all sorts of things. And I've tried to add 3D packages, 3D models to as many of these parts as possible, because I'm now so much in the habit of working in this mode where I'm looking at the schematic, the PCB, and the 3D model all at the same time on the three screens, because the the physical shape, the 3D model of the device ends up informing changes that I make in the schematic. It's I suppose the traditional way of doing electronics design is you start with the schematic in isolation, you finish the schematic, you throw it over the wall, you do the PCB layout, possibly with some constraints like physical dimensions or whatever, and you finish the PCB layout. And then you throw it over the wall to someone who has to do the enclosure design. And so they have a completed PCB and they have to design an enclosure around it. So that is kind of the way electronics is generally done in, you know, any largish project. But the really nice integration between Eagle and Fusion 360 in recent times has really changed my way of going about it. I find that being able to see the physical end result really early in the process, even while I'm working on the schematic, is very, very helpful. So I try to, like, I'll do some work in the schematic and, you know, a rough board dimensions and things first, sync it into Fusion 360 and pull up the 3D view. And from that point on in my development process, I could be making changes in the schematic, but those changes I am reasonably frequently syncing through to Fusion 360. It varies. I might go hours or days without syncing, but there will be certain times where I'm working on part of the project and I might be resyncing with Fusion like every 10 or 20 minutes because I want to see the most up-to-date 3D view of what I'm working on. So it becomes much more of a cycle rather than a linear process with 3 distinct stages and just throwing it over the wall each time. And I found that having that visibility of the end device as a physical object and being able to conceptualize it as a physical object helps with decisions that are made earlier in the process or at the earlier part of the cycle with things like selecting switches, or I mean there are the obvious things that are constrained by or interact with the physical artifact. Things like switches and connectors are the really obvious things. But there are other things as well, like the positions of LEDs on the board, or how many, like what LEDs you have for display purposes, or whether you decide to put a little I2C OLED on it so that you can get feedback and use that as another way of interacting with the device. Or it might be even things like how the user uses it. Like you might decide, for example, early on, you might decide that you're going to put some buttons on it. So you put the buttons in the schematic, and then when it comes to actually representing it physically, you think those buttons don't really make sense. It would be much easier to interact with this device if I had a menu system with a knob and a button, so I could select menu items and then press it. And being able to see the end result of how someone is going to interact with this device then informs how you go about the design process. So I would like to share my Eagle libraries. I just haven't looked at what is involved in it. I need to excuse me, I need to do a little bit of reading because Eagle has been under such rapid development recently, and also now of course things are rolling into Fusion 360. The whole game is changing in terms of how this software works, and I simply don't know how to share these libraries. I could probably just export them in legacy format as a .lbr and then people could grab them but then if I update them, I need some way of people getting those updates, and what would be really nice would be to make this collaborative and have other people add things in here. Like say someone wants to, someone has a fork of my library and they want to add, you know, the 6-pin version of this keyed header, so they add it in here, and then I merge their change back in. So it would be really nice to be able to treat a parts library like a software project. You know, the way we have, you can take a fork of a project, you can make some changes, then you can do a pull request and then merge those changes back in, and that would be super cool. I just don't know what's possible. Okay. I just saw some interesting questions in there, but I need to get back to looking at the chat. So, the questions are. Look at this. I'm at 11:46, and my list of questions is way off the page, off the screen. What can I say? Okay. All right. So. There was a question, which is, have any Freetronix customers let me know of some of the more interesting EtherUNO or Ether10 uses? Well, there was one Ether10 use that I came across, this was a couple of years ago now, which was, so the Ether10 is a little Arduino Uno compatible board with onboard Ethernet and power over Ethernet. And this particular use was in a chook shed, or in multiple chook sheds in I think it was in Queensland. And in these particular chook sheds, so this is on a chook farm, you know, this is not someone's backyard with 6 chooks. This is like where they have sheds of tens of thousands of chooks. And they had a big ventilation system, so they've got blowers that move air through the shed. And the blowers are enormous. They're the sort of fan you see on a sci-fi show where the fan itself might be 3 or 4 meters across, and they have multiple of these fans at the end of the shed, and they move air through it. And they also need to monitor environmental conditions, so they want to make sure that the temperature is good. You know, nothing is that the chooks are in a good environment. So what this particular customer did was, so this customer was running a chook farm, and they bought a number of dot matrix displays, which are the display panels that they've got 32 by 16 LEDs, and you can panelize them together to make enormous display boards. And they mounted some of those dot matrix display panels and an Ether10 on the wall up the end of the shed, and it was taking environmental data and displaying it up on this huge illuminated panel. So you could see the panel from, you know, miles away and see the temperature in the shed and make sure everything was going fine. And that was running with power over Ethernet and getting data updates from sensors over the Ethernet connection. So that was kind of an interesting application for an Ether10. I mean, there are many others. I've got customers that buy them and build them into commercial products, and which I can't mention. I've sent Ether10s to many places, including the Australian, what's it called? There's a place in South Australia where I think it's part of the Defence Signals Directorate, where they do development of interesting stuff in relation to the army that okay, let's not get into that. Okay. Oh, this is an interesting point. Both Sion and Johnny Bergdahl said this, that I don't need to share the library as all the components are copied into the design files and you can export any component from those. That is true. If you grab one of my projects off GitHub, and I think pretty much everything is on GitHub, even incomplete projects, then you open them in Eagle, you can export the parts directly out of the project, because the way Eagle's file format works, when you add a part to a project, it doesn't just make a reference back to the library. It actually takes the complete part from the library and copies it into your project. So your project is self-contained. You can take the project file, open in Eagle. You don't need the libraries installed to open the project and see everything in it. But that is not great from the point of view of being able to collaborate on libraries. It doesn't really solve that problem. And so what I would really like to be able to do is make these libraries more collaborative. And it also means that you only get the parts that are in that particular project. So if there's a specific part that you're interested in and it's in a project, you can get it. That's no problem. But what would be really nice is for me to be able to share these libraries and someone just download the whole library and they've got everything. All the 3D models, all the footprint variations, everything. So that's what I would like to do. Yeah, oh, okay, so Johnny Bergdahl said, yeah, I've moved the origin point to the middle of the component just to solve the PNP thing. So this is showing how far behind the chat I am. And so there was a question from user 34638A, awesome Nick, saying you were talking about how TLS was harder to support on the ESP8266 a little bit ago. Can you elaborate as to why? So I can give you a very general answer, but this is outside of my field of expertise. Alright, so what I'm telling you, take with not just a grain of salt, but like a little teaspoon of salt. So doing any form of encryption on a processor is, I don't understand it enough to be able to explain it properly. Basically, you need a processor that has a few attributes, and you need access to certain things. For crypto, you generally need access to randomness is one thing, and that is harder than it sounds. You need a processor that is fast enough to be able to do some kind of gnarly maths, and it needs to be able to do it quickly enough that that it can that it cannot take too long to respond to things. So it needs to be able to do things in relation to prime numbers, and it needs to work hard basically. So you can sometimes offload crypto to co-processors, but in a little embedded project, normally the crypto is done in the main processor. And so if it is not capable of running the algorithms that are used for the things like the encryption and decryption, etc., then you just can't implement it in a low-end processor. It is so long since I've done crypto stuff that I'm going to be talking absolute rubbish, so I'm not going to go into that in much more detail. There are people way smarter than me that work on that and do know what they're talking about. Superhouse Eagle Library. Oh, okay, so Pancake Legend said in KiCad I often use the user drawings layer to draw additional reference lines, typically on a grid. Yeah, that could be a handy thing. There are different layers in Eagle as well that could be used for that purpose. So there are some interesting tricks. There are a number of tricks in relation to drawing things like footprints and getting spaces on pins. I am so tempted to detour into this and chase this squirrel right now. Alright, let's do it. Nothing like a squirrel hole at the last moment. Alright, so let's switch back to desktop, and I haven't planned this at all, so I'm going to have to think about how I do this demo without messing up this library. Alright, let's say I have got I've got a pin with an even number. How do we do this? Alright, I'm going to just screw around with a footprint. Let's take an existing footprint and duplicate it. And I'm going to just call this temp and edit it. What happened there? I have no idea. 106 temp. Wonder if Eagle is going to bomb out on me now. Alright, so we've got this footprint. Hang on, I need to move it so that you can see the menu for the grid. So, one little... Oh, maybe this would work better if I did this demo on a PCB. Yeah, let's see if I can figure this out in here. Alright, so grid. Let's switch it to millimeters, and I'm just going to make it a 1 millimeter grid. Now, if you have a part, like let's move this part over here, move this, oops, come on, give me the, what is, oh, the tool mode switched, let's get rid of that, window, yeah, the tool mode, no, that, I want that part over there. Alright, so, this is it's a kind of trivial trick, but I find that this is a trick that is useful in different situations, and that is changing the grid to suit where you're wanting to position things. So say we've got, let's put this at X position 0, so this is now, you can see all sorts of rendering artifacts on here, that's weird. So this pad is now at position 0 relative to the origin. It's pushed up a bit in the y-axis, but that doesn't matter. So let's say, I'll move that down there, let's say we wanted to put this on an offset where you can see that I've got a 1 millimeter grid. If I zoom in, you can see that this part, because this is a 0.1 inch pitch pad, is, I'm going over this in my head. This is a really bad demo. I should be demoing this on a PCB because that's where things are much more useful. There's a particular technique that I'm trying to demonstrate, but putting it into a concise way of showing why it's useful is not that easy. Alright, we've got a... Nah, I'm going to give up on that. I'm going to think about this and do this as a better demo some other time. I'm going to close that without saving it, save no, and I'm going to close, so the library I've closed and I haven't saved it. Alright, I'll get back to that. Alright, in that case, since I'm bailing on that, let's get back to the questions. Yeah, there was a question from Sam Gallen saying, is there any way to use ESP by Ethernet since I want to have advantage of Tasmota firmware and being on wired network? Now, there are two different parts to that. The first part is any way to use ESP with Ethernet. Yes, and there is a particular project that is worth looking at, which is the WESP32, WESP32. And let me see if I can find a URL for that. WESP32. This is a cool project. WESP32.com. Oh, there it is. Okay. So it is the most obvious URL ever. I'm just going to stick this in the chat. And so WESP32 is an ESP32 board with power over Ethernet. It's got hardwired Ethernet and power over Ethernet support. So if you look at that project, it'll give you some really cool ideas for things you can do with that. However, there is a second part to your question. So the first part is yes, you can do hardwired Ethernet with ESP32. The second part was Oh, actually, you might have been talking about ESP8266. Sorry, I didn't look at that part of the question. So the next thing is Tasmota firmware and being on a wired network. I don't think Tasmota supports... Oh, I wonder if this is an issue. No. So Tasmota will not support wired Ethernet. That's the fundamental issue. I'm pretty sure it doesn't anyway. Tasmota will run on an ESP8266 or 8285, which is the same core, with Wi-Fi, and that's really what it's focused around. Now, as my friend Andy pointed out to me last week, there is an initiative to make Tasmota run on ESP32. So you can get Tasmota on ESP32, I believe now. It does run. But I think it's unlikely at this stage that Tasmota will support the hardwired Ethernet driver. Given that the ESP32 can do so much more, I wouldn't be surprised if at some point the Tasmota branch for the ESP32 does support wired Ethernet. But at the moment there are very few boards that are ESP32 with wired Ethernet, and there is also, the focus of Tasmota is very much on the ESP8266, which means that there is very limited flash, and it's a less powerful processor with less memory, etc. So anything like adding a driver for a device that is a real unusual situation, it won't end up in the standard Tasmota release. You would need to do a custom build, is my guess. So there is no easy answer to solving that problem. It falls into the category of, you could probably get Tasmota running on an ESP32 with hardwired Ethernet and add in the hardwired Ethernet driver support yourself, but you're not going to be able to just download it, install it, and have it work. It'll take a bit more work than that. Okay. Oh, Adam said, during your lab tour, you didn't show us your network closet. Can you do that on a future stream? Yeah, sure. Yeah, so I've shown those on videos in the past, but not for a long time. They haven't changed all that much, but yeah, I could grab the portable camera and go and show you through. I won't go into that right now. Short answer is yes. We'll get back to that. And the follow-up from that was also, would be great to have a live stream topic covering what you would do with your home automation system if you were to start from scratch. Yeah, that is a really good topic. And that is the sort of thing that has come up on the Discord not all that long ago. And the reason it's come up is that there are a number of people that are in that situation. They might be doing a new build. I think this was all prompted by someone coming along to the Discord and saying, I'm building a house, what should I do? And there were a whole bunch of suggestions. And there is a page, where is it? There is a specific topic on the forum, the Superhouse forum. I'm just going to see if I can find it now, hopefully without taking a huge amount of time. Oh, here we go. Building a new house, post your Superhouse automation ideas. I'm going to stick this into the chat, and this is the forum thread that has been going on since June, and it has quite a few posts in it, which is people talking about planning ahead, and if you are building a home automation system from scratch, what things should you do? Oh, hang on, I think I just gave you, the link I gave you was actually to down in the thread a bit. You need to go back up to the start of the thread. In fact, I'm going to redo that. I'm going to put in that same URL. Here we go. That is the thread with ideas. And so this is not directly answering the question of what I would do differently, but yeah, I think that's a really good topic for a future live stream. If I was starting from scratch, what would I do? So following up from that ESP32, Magic Blue Smoke said, as of now, ESP32 does work on Ethernet with Tasmoda, as of 10 days ago on the documentation on a specific board. Whoa, that's cool. Very interesting. What I don't see in the immediate future are budget manufacturers switching devices they currently make with an ESP8266 over to ESP32. I think ESP8266 is going to continue for some time on Sonoff class devices where a manufacturer is trying to make it as cheaply as possible. They want Wi-Fi connectivity. They don't really care that much about security, to be honest. Like, they just want a cheap Wi-Fi connection for their device, and they don't want to pay 10 cents more for another chip like an ESP32. They will just keep using ESP8266. But what will be really interesting is people who are building their own devices. Like for me personally, for example, if I've got a choice between using an ESP8266 and an ESP32, I'd rather put in the ESP32 because for my personal projects, maybe the chip costs a little bit more, but it can just do so much more. It opens up, you can run MicroPython and you can do all sorts of really cool stuff on it. And it is so much more capable than the ESP8266 that for me, for my projects, I would rather go for an ESP32. It's just a better chip. And the small difference in price doesn't bother me at all. It's totally worth it for the benefits. And so what's going to be interesting now, I'm going to have to check this out. Thanks Magic Blue Smoke for pointing that out. What's going to be interesting is seeing people building projects where they use an ESP32 and run Tasmoda on it. It's going to open up some possibilities. Tasmoda on ESP8266 now, in fact for a long time, has been at the point where there is no way to compile it with all of the options. It's just in the resulting program, there is no way it's going to fit into a typical ESP8266 sort of device. And the other thing is you have to allow for the fact that a lot of those devices are using the ESP8285, which is the 8266 core, but with 1 megabit, I can't remember, of built-in flash. It doesn't have an external flash chip. I think it's 1 megabit, which is actually a very small amount of memory. And so you cannot compile Tasmoda with a bunch of options turned on and then still install it on a device. You have to be selective about what options are enabled and then compile one to suit your particular target. And a whole lot of the Tasmoda project over the last year or two has been about the process of building all of these different binaries for different purposes and collecting things together. Like, do you include a driver for a display when it takes up memory and most target devices don't have a display on them? Those sorts of decisions. But with ESP32, it opens up the possibility that you can have a whole lot more stuff running on it. Cool. Okay, so there was a question from Aaron, and this funny thing is that this question is something I was thinking last night for a project that I'm going to get back to. Off-topic question. Are you aware of a similar board to a Pi 0W with a little more power and memory, etc.? Same small/slim form factor. Looking to use it to run a letterbox 15:3 touchscreen panel and want to run a headless Chromium browser on it. Ideally want Bluetooth and Wi-Fi and possible USB-C to power the board and screen. Alrighty, so the reason I was looking into this just last night, and I don't have a great answer. There are things like the Orange Pi 0W. The problem I've had with alternatives to Raspberry Pi is that so many of them use things like there are variants that run different Allwinner chipsets, and so They have very specific software stacks that you can run on them, and what you do by switching to I'm making a big generalization here. This is not always the case, but what you often do in switching to a board, if you're used to something like the Raspberry Pi ecosystem and all of the code that you can run on it and devices that you can plug into it, like hats and peripherals, and being able to plug in a USB on-the-go thing, or plugging in an external USB Ethernet adapter or whatever, or a camera, you switch to another board that looks very similar, and it has similar connectors on it, but it uses a different chipset, like a different version, All-Winner chip or something. All of a sudden, all of the things that you are comfortable with and accustomed to just don't work, and you have to use a very different software environment, and it can just be really disconcerting. Now, that's not necessarily that those are, I'm not saying in any way that those are bad devices or bad chipsets or whatever. It's just that if you are really comfortable in a certain environment and you've been working in it for a long time, and then you switch over to a different environment, there is going to be a period where you have to get your head around different ways of doing things, or things that were working on this environment don't work in this environment, or you do things in a different way. You can solve the same problems, but you have to solve them in a different way. And there are a couple of times where I've used things like Orange Pi as an alternative to a Raspberry Pi, and then I've tried to do something and discovered that no, it just doesn't. It's different on Orange Pi. So there are these little speed humps you have to get past. So the project I've been working on, that I've been looking into this for, is building my own Wi-Fi access points specifically for IoT devices. And this is it's not just a squirrel, it's like a whole clan of squirrels. So I'm not going to chase this right now. This is a whole big thing that I'm going to cover in the future. I have been, for quite a long time now, in fact for I think about a year, experimenting with my own access points, which are Raspberry Pis, and they're doing a little trick called personal pre-shared keys. So the problem with IoT devices, like a Sonoff, this actually ties back to what we were talking about earlier. A Sonoff running TAS motor it can't support enterprise authentication. So if you have a typical Wi-Fi network, you have an SSID and you have a password. And so someone comes over to your house and they say, "What's your Wi-Fi?" And you tell them, the SSID to connect to and the password. It's the same password you use. Now, I'm ignoring guest networks and all of that sort of thing for now, but just think about it. On a Wi-Fi network, every device connected to that Wi-Fi network has the same password. And that could be a problem. If a device is compromised, maybe whoever has compromised that device now has the password for your Wi-Fi network. If you want to change the password on your Wi-Fi network, think of all of the devices you have that are logging into it. You have to go around and change that password on all of those devices. The whole thing of a single shared password for a Wi-Fi network is horrible and painful. What you really should be able to do is it's like creating users, or if you want to give a device access to your network, you should be able to generate a password for it, and it goes into that device, and it's the only device using that password. And at the enterprise level, so say you're running an office. Imagine you've got a small office and you've got 20 or 30 staff in it, and you've got Wi-Fi, and one of your staff members leaves. Now, they know the Wi-Fi password. It's not a simple matter to just say, "Oh, we'll change the password," and have everybody change their devices. That would be really annoying. I mean, you can do that sort of thing in an office of 20 or 30 people, but imagine you were running a company and you had 1,000 people, and you've got a Wi-Fi password. Change the Wi-Fi password. That'd be chaos. So the way that's done at the enterprise level is using a different authentication scheme. Now, I'm over time, so I'm not going to go into this in great detail, but this stuff is really interesting, and I am going to go into this in detail later. So what is done in that situation is that you create profiles for different users, and this is what's typically done in places like universities and large companies, anywhere that you have a large number of users that are trying to connect to the network. So what you do is you create a profile, and typically they're tied back to an authentication server, which might be something like a Radius server. And so the Radius server maintains a list of all of the users and their passwords, and it's a challenge response system. So a device wants to connect to the network and it says, hey, I'm here and this is my username and this is my password. I mean, I'm dramatically simplifying things here. There's handshaking and keys and all sorts of stuff going on. But what happens is that the device presents itself and says, this is my password, and that goes to the Radius server, and the Radius server looks it up and says, yes, you are an authorized user and you sent me the correct password, so I'm going to send back a token and to the access point, and the access point now says, yes, you're allowed to connect and you're on the Wi-Fi. The problem is that all of those sorts of schemes you can't implement in an ESP8266 for the reasons that we were talking about earlier in the live stream. It doesn't support the encryption necessary. It just doesn't have the processing power, the memory. It doesn't have, all the attributes necessary to do the proper crypto to support enterprise level encryption or enterprise level authentication on a Wi-Fi network. So, getting back to this whole thing about building my own access points, this is the reason that I've been doing it. What I've got running on my little homebrew access points is an authentication system which uses what's called personal pre-shared keys. It has a different name. People call it different things because it's not it's not an actual standard. It's just it's a trick basically. It's a party trick. So what happens is when with this trick, you don't run enterprise authentication. You run the standard WPA style authentication, which we're all familiar with. That's the standard of SSID and password. But what you do is, instead of having a single password for all devices on your network, what you do is in your authentication system, you have a list of MAC addresses and passwords. So when a device connects to a network and says, hey, I'm here, I am a Sonoff, I'm running Tasmoda, and the network knows the MAC address of the device, and here is my password, it looks up its list and says, this MAC address has this password, yes, I will let you on. And it then lets the device join the Wi-Fi network. So the end result is that you can run low-end devices like Sonoffs that can't support enterprise authentication while still having unique passwords for every device. And it means that you can create a profile for the device and then give it the unique password. It connects to your Wi-Fi network and no other device knows its password. That's the brief summary. Anyway, I've got all of that running, and what I've been using for that is just regular Raspberry Pi 3s. I've got it running on a 3B Plus that was on the bench over there, and another, I think an older Raspberry Pi 3. So what I've just been looking at is now turning that into a proper project and doing a video about it and releasing it and documenting it and all of that sort of thing. And what I've been just thinking about recently is making these little homebrew access points aesthetically nice and also convenient. So I've been thinking about 3D printing an enclosure, and of course because I've got Unify gear through my house, I've been inspired by the aesthetics of how Unify is done. So I've been thinking about making an enclosure that I want to be able to 3D print and have a bracket that you attach to the ceiling, and then an enclosure, maybe a circular one like a Unify access point, I don't know, a little bit like a smoke detector that you can put into so you have Ethernet coming through for the backhaul, plug it into your device, you clip the enclosure on, twist it, and it latches into place. So you have a little thing that's like a little UFO stuck to the ceiling, and that is your access point. And inside that is a Raspberry Pi type device that is acting as one of these little access points that's running the personal pre-shared keys magic trick. And then you can install a few of them around your house and run a Wi-Fi network just for your IoT devices while maintaining a higher level of authentication security than in a typical Wi-Fi network without needing to support enterprise authentication. So anyway, future project, but, well, current project, future in terms of releasing it. And that is what I've been thinking about recently. So just last night, I was asking myself almost that exact same question. What board is similar to a Raspberry Pi Zero W, but with a little more power and memory and in a slim form factor? And in my case, I need Ethernet as well. But what I'm possibly going to do is make a carrier board that the little Pi or whatever will plug into, which will have Ethernet on it. So I could use, what I've been planning to do is do this using a Pi Zero W with external Ethernet, and I'll make up a PCB with like some vertical mount RJ45 sockets, so that I'm waving my hands around. What's an example I can use? I can't really see one. So imagine this is the device. It's like a shape of a little UFO, and I want to be able to attach it to the ceiling, have the cable come out of the ceiling with the Ethernet plug on it, and plug it into the back, and then put it into the bracket and clip it in place. So I'll have like some vertical mount, I have a vertical mount Ethernet socket on it, have some LEDs so that it can show status, just like a Unify gateway. And yeah, so I don't have an answer at the moment. I have just been looking at it, but hopefully I will have an answer soon. So the Orange Pi Zero W does look interesting, and there are a couple of others, but I don't really have an outcome of that right now. I haven't looked at a whole bunch of options and said, yes, that is the one I want to use. But that was a very good question, which I have now totally failed to answer. Alright, so alright, two things to wrap up. Both of these will be quick answers. I promise, I promise. James O'Gorman said, okay, I have to ask, did you ever run Blink on ArduSat while it was in orbit? The short answer is no, because I did not have direct control over the operation of the satellites once they were on orbit. So I did the development of the hardware, and but I didn't have access to the management console to be able to do software updates once they were actually deployed. But that would be funny. And there was, where is this? I'm going to find this. Was it FitSat? I think it was FitSat 1. There was a satellite that was put up by Fukuoka Institute of Technology, which was a blinking LED in space. This is actually kind of cool. I'm going to find this. I think it was called FitSat 1. This was a long time ago now. Ah, yes, here we go. So this was deployed in October 2012. And I have a feeling that this may have actually... Oh, no. Was it? I don't remember. I think this one might have been deployed... It was deployed from the ISS, but possibly a little bit before... here we go. TechHeadsat F1. Okay, I'm going to drop another link in the chat. This is a link to the Wikipedia page of FitSat 1, which this sort of thing just blows my mind. It's a CubeSat satellite which uses magnets so that it orients itself on the Earth's magnetic field, so that it's always in the same orientation with the same face facing Earth. And they put LEDs all over that face, and they just made it blink. So the idea was that the satellite would be traveling through the sky and blinking out messages in Morse code as it traveled, and you could just look up and see the blinking LEDs on the satellite. So, I mean, there's more to it than that, but that is the that is the outcome. I love that project so much. Blinking LED in space. So Frank McAllendon said, any progress on your lighting switch controller? No, sorry. I've been distracted by a number of things. One is I've been doing a lot of contracting work over the last month in particular. Contracting has just gone crazy, which has stopped me from working on a lot of things. And the time that I have had to work on other projects, I've been doing things like finishing off the EtherUNO. The problem is I have got so many projects in parallel at different stages of development that I want to be able to get some of them to the point where I can say that is done and wipe it off my list. So the EtherUNO was becoming kind of time critical because of drying up supplies of the WISNet W5100, and I need to be able to keep producing an Ether 10 equivalent board, so the EtherUNO is the replacement for that. But that now it's working. It's all doing what it should, so that'll go into production, which means that one is off my plate. I do want to do the Ether Bear, which is the same thing but with the W6100 for IPv6 support and an ATmega 1284p processor for memory. But the light switch controller is something that I really, really want to get back to. For me personally, that's an important one. Right now though, no other progress to report, unfortunately. The very last thing, so DIY in the Ghetto said, is it possible to do home automation without using something like MQTT? Just curious. Yes, it is. You don't need to use MQTT. There are many home automation systems that don't use it, particularly home automation systems that are kind of like a monoculture. So if you have a whole lot of devices that all come from the same manufacturer and they are designed to be integrated, then a platform like MQTT has less value. But the real killer of MQTT, the huge benefit of it, is that it gives you the ability to integrate devices that weren't designed to work together specifically. MQTT is, I'm trying to think of an analogy. It's like, imagine, all right, think of it as languages. Imagine you had to organize a meeting between a bunch of people, and every single person spoke a different language. There was no common language between them. You could do that, but it would be hard. If you have the meeting and everybody speaks the same language, it's easy. You can communicate easily. So what MQTT gives you is the ability to communicate in a common way across devices and link them up in different ways. So if, for example, you wanted to just drop a bunch of money and install a Clipsal CBus system in your house, then you don't need an MQTT broker because the system is integrated. All of the devices are designed to talk to each other. They come from the same manufacturer. But if you want to build a home automation system, which is much more DIY, and you have some Sonoffs and you have some Hue light globes and some LifeX light globes and you have some other smart switches and you've got some Zigbee temperature sensors and whatever, you've got a whole mix of different things. That is where a messaging system like MQTT just makes, I was going to say makes everything easy, but it doesn't make it easy. What it gives you is that common language that you can make all of those devices communicate through. And so short answer is yes, you can build a home automation system without using something like MQTT. Oh, and I should point out that there are other messaging systems. I talk about MQTT all the time. It's what I use. It's in terms of like DIY IoT space, it's pretty much dominant, but it's not the only messaging system. There are others, things like RabbitMQ, and so there are different messaging and queuing systems, but for me, I wouldn't even bother looking at anything else at the moment. MQTT is where it's at. It's what everything that I care about talks. If you're building a different system, maybe you would choose a different messaging platform, but that's the one I'm using. Oh, James, thanks for that super chat. Yeah, so I really appreciate that, and thank you for hanging out with me. So there are a whole bunch more things that I could talk about. Oh, okay. There are a couple of things in here that I will just clarify in relation to my personal pre-shared keys thing. So Jeff Miller said, you don't use a Radius server to give all clients individual passwords as a question. So I think that might have been a question to someone else. And Stephen W. said, you can potentially use Radius, but that's likely too complicated for an IoT application. Unify... okay, I'm not going to get into that too much. Radius itself does not solve the problem. The Radius acts as an authentication server where, in fact, you can use Radius for all sorts of different things. It is really just it's a way of sending a query saying, here is a user and a password, is this authorized? And you get back a result and some other data potentially about what services they're allowed to use, etc. But let's ignore that for now. Basically, it's just a way of saying, is this password good or bad? And if it's good, then you let them on. If it's bad, you don't. That part of it is not the problem. Radius, you can set up, and you can run free Radius. There are open source Radius implementations. That's not a really big deal. The issue is more what you do at the access point. So the access point itself needs to be set up in such a way that it receives the connection request from a Wi-Fi device, and then it knows to go and ask the question. So the little bit of magic basically is in the software that is providing the access point, and doing more than just comparing the password that it's given against a single known password. It has to know to go and look up using the MAC address and the presented password against some external reference. So that's where the little trick is in the configuration. Anyway, I will go into all of that in a lot more detail in the future. But for now, I'm out to 2.5 hours, so I've got to call an end to this. So thank you very much for coming and hanging out with me on a Sunday. It has been cool. I didn't know what I would talk about today, but once again, there always turns out to be more than I expect. So I will see you all later. Have a great Sunday afternoon if that's what it is for you, and I will see you hopefully on Discord or somewhere. Talk to you later. Bye.